Hello and welcome to the introduction, section 1 to CNC machining. This is the overview of the entire CNC text. We'll be only covering a portion of it, but this is the first portion. Okay, I'm going to briefly cover the manual, history of manufacturing, history of CNC, and then we're going to get into actually what we're going to be doing, the CAM process, the computer-aided manufacturing process, which is what we will be using to make our projects using the CNC machine to cut them out. Okay, so let's get started. The introduction to the manual is covering what it is to work in a modern manufacturing environment. This is just a modern manufacturing tool, and there is the possibility of using CNCs to make houses now. So the progression of this technology has led to large whole structure creation, and it uses concrete pumping. It is similar to a 3D printer in that it's an additive process. Okay, so why is it important to know this? Well, this is a good background information to know as there's more and more robotic tools that construction workers use. Okay. We're going to continue with the summary here. The completed process used in this industrial production will present students with a part. A part in this case is going to be the phone project. This is what we did the design process on. So we will take that computer drawing and turn it into a physical part made out of wood using our CNC router, our Techno CNC router. Okay, so this is our trainer that we have here in the classroom, and this is what we're going to be using to make the part. But it's important to know the historical aspects of what's going on. Okay, so let's get going. A brief history of manufacturing, and boy, it's going to be brief. To summarize all of this, manufacturing used to be all done by hand, and there was no uniformity in the things that were being made. That was very difficult when you wanted to repair something. Things were very expensive if they were mechanical, and not everyone had access to mechanical things. Now, in our modern society, things are very inexpensive and disposable. This is opposite of how it used to be in the original times, the historical times. And so right here we're looking at a machinist's tool chest from the 1860s. Okay, so that is, if you didn't have your own tools, you made them, and so this was actually a very complex process. Moving on, limitations. Limitations are overcoming people's limits and increasing different capacities that we have. So by using gears, motors, and other tools, we're able to use our intellect to overcome certain physical barriers. The role of information and knowledge. Technologies is used to satisfy and overcome limits that were developed from knowledge. What does this say? The technology is a substitute for you training under a master for several years and then having that information passed down to you. By you being a person who can use technology, you are essentially fast forwarding your progress in the manufacturing sense, and the robot can help you with your skills. Your deficiency of skills, so that now it is helping you do something in a skilled way, simplifying the process. Historically, we have Johann Gutenberg, who developed the printing press. This is probably one of the first examples of mass production. Before he invented the printing press, books were all copied by hand, so books were very expensive. Books are now having their own issues because books are not as fastly available as internet content or digital content. So there's even a faster way besides books to get information. But during this era, you're looking at the 1454 era, you're really talking about the initial inception of how information was passed from one person to another person. If it's not through the spoken language, it was through a book. Okay, so then we started to enter the Industrial Revolution, and machines started to be made more widely available. In this way, the parts and components of everyday life started to become cheaper. Okay. Here it says before the Industrial Revolution, 90% of the United States was agricultural. Now we have many different industries. Our industry that we are in is called construction. Looking at some new machines that were developed, here we see antiquated examples of the modern machines that we use in class. Sources of power. Power itself is actually a technology, and electricity was not widely available. Windmills and water wheels were the source of power in the past. Here we see a steam engine. The steam engine is an example of when heated water started to be used as power. Developing this created an engine, and this engine technology, first with the steam engine, then later on the internal combustion engine, were very big strides in harnessing actual power. This is power as mechanical force and power as electricity. The first electric motor constructed by Joseph Henry in 1831. Wow. So in only a few hundred years have we been able to go from the first electric motor to where we are in our human technology progression. New materials are also part of what happened here in this progression, and new materials meant the refining of raw materials into alloys and more robust materials. Perhaps one of the three most important elements here are steel, aluminum, and plastic and chemicals. So these four things are very essential to everything that we do, the industrial manufacturing process and construction. Here we see all these bicycles, and this picture is attributed to Henry Ford. First developed mass production in the form of the assembly line in 1908. So this is the precursor to the modern robotic assembly line, which was this was done with people in only 1908. Mass production. When we look at mass production, we see that these are the so-called heroes of this time. And I'm not going to go into each of them too much, but I will say that these are the most important figures in manufacturing history. Very quickly, Eli Whitney had the idea for interchangeable parts. That's a standardization of parts so that you can just go and get parts that fit in another machine that were made by another person. Before he invented that, that didn't happen. Also, a principle he developed was the division of labor, and so people could specialize in different components of the manufacturing process. Continuous flow is another mass production aspect, and that has to do with the assembly line, and so the work is moving from one workstation to another workstation in a rotation. Okay? So this was the product that was being manufactured moves, and the workers stay stationary. Probably one of my favorite so-called heroes in this history lesson are Frederick Taylor and the elimination of wasted motion. He is like the father of time studies and wasted time. One of the most interesting things that this person developed was a shoe that didn't have shoelaces. Because he was so efficient, he determined that shoes that needed to be tied took up so much amount of seconds every day, and that eventually took up days of your life just tying your shoes. He also specialized in a study about shovels and the right shovel size to shovel coal, and then did efficiency studies on the output of the furnaces that coal was shoveled into. So he looked at efficiency from a time standpoint and was trying to squeeze out all of the efficiency that was possible. I'm only trying to touch on the highlights here as we continue on. This is more about cars and vehicles. Quality control. Quality control is very important, and this is about a statistical approach to what you are making and the measurement of what you are making to know that whether you made it correctly or not. I'm not familiar with this area here, the relationship between quality and productivity, but I would like to especially mention just-in-time. This is something that is still used today, and this is manufacturing on a schedule and understanding how the schedule every minute, every second of every day impacts a schedule in making a product. It's about efficiency. The Industrial Revolution caused a change in American society. Yes, because as goods got cheaper, more people could afford goods, products, clothing. Clothing is very important in this because clothing, now that it's not made by hand anymore, at this point in history, could be afforded by other people very cheaply. At a point in history, all the clothing was made by you in your own home, like you or your family would make your own clothes. Because clothes were so expensive to buy, you could not buy them. You would most likely have to make them. The role of the government. If we talk about the role of the government, this would probably, where we are in our studies here, this would probably go into OSHA. The initial manufacturing process was very deadly, and people would die on the job regularly. This could be problematic because there was no recourse for their families if they died on the job. Then there was different regulations that were put in place to protect workers' rights and workers' safety. And so what we study here, OSHA 10, is an introduction to that. Let's see here. New manufacturing techniques. We don't talk about too much of those, but we are emphasizing CNC technology here. Disruptive technology. Disruptive technology is a technology that's replacing previous standards of technology. So these things are like your life as you know it. You've probably had interactions with cell phones most of your life, which are actually portable computers, video cameras, and audio recorders, and communication devices. It is only recently in human history that everybody has one of these all the time. So this is a relatively new development. In this case, what are the effects of disruptive technology? Well, that's going to be like saying, what was life before computers like? Well, everybody had to do calculations by hand, drawings by hand, pencil and paper, or pen and paper. Now we use printers. Now we have digital tools to make things. It's very different. The amount of skills you need to get along in the modern world is quite complex. Okay? Now that we all have computers and are familiar with computers, we can actually control machines with computers. So this is really where we're finally getting to the part where our lesson connects with the historical context. Okay? And here we are at CNC manufacturing. Okay, I'm going to go ahead and pause the recording here.